Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. I'm really excited about today's topic. We're diving into some fascinating research about using personalized dietary interventions to blunt the impact of electromagnetic field exposure, specifically focusing on 5G and other wireless technologies.
Yeah, this is a big one. I mean, EMF sensitivity, whether it's real or perceived, is causing a lot of people a lot of stress. So finding ways to mitigate that, especially with something as accessible as diet, is pretty important. And of course, we're looking at a very cool paper, right?
Absolutely. And it's not just about feeling better, but about understanding the actual cellular response. This longitudinal study aims to link dietary strategies, cellular reactions, and long-term health outcomes. That's the kind of holistic approach I love.
Right. Okay, so for anyone just tuning in or, maybe not super familiar with the science, the study's title is Oblique Thick Light Sheet Microscopy with spatial-temporal 3D localization for RNA imaging in intact 51 thick sections. It might sound like a mouthful, but it's really about being able to see what's happening inside our bodies at a very detailed level.
Exactly. The core of the study revolves around this advanced microscopy technique. It allows researchers to visualize RNA activity within thick tissue sections. It's 50 micrometers, which is like amazingly thin, without having to disrupt the tissue structure too much. Think of it as peeking into a living cell without really disturbing its natural environment.
And that's key because the less you disturb the cell, the more accurate your observations are. It's like trying to study animal behavior in the wild. You don't want to cage them first. This technique offers a much more natural and realistic view.
It's funny, reading about this technology, I was immediately thinking about lifestyle changes, about life hacks, even meditation. The idea of using this to actually see the effects of those choices on a deeper level is incredibly exciting. Like, can I see the effects of a mindful walk on my RNA?
That's a great point. The visualizations are incredibly important. If you can actually see the impact of something like stress on RNA activity, then you can start to build a stronger case for cognitive techniques. Imagine seeing the RNA activity shift after a CBT session designed to address EMF-related anxiety.
Yes, and it opens the door to personalized exercise and sleep recommendations. If we can see how RNA responds to different types of physical activity or sleep patterns, we could optimize our routines for maximum benefit. Maybe certain RNA patterns indicate optimal recovery windows,
Okay, so let's break this down for someone who's maybe not a molecular biologist. RNA, ribonucleic acid, is like DNA's messenger. It carries the instructions from our genes to make proteins, which are the workhorses of our cells. So by seeing where RNA is and what it's doing, we're essentially seeing what instructions are being carried out.
And these instructions are constantly changing based on our environment, our thoughts, our diet, everything. That's what makes this research so powerful. It's not just looking at static genetic code, but the dynamic real-time activity of our cells.
Exactly. Think of it like a recipe book DNA and a chef RNA who's constantly adapting the recipe based on the ingredients available, our diet and environment, and the desired outcome, our health. This technology lets us watch the chef in action.
Right. And the fact that they can image RNA in a 50 micrometer thick section is pretty amazing because it means less invasive and potentially less stressful for the tissue. That opens up avenues for more sophisticated lifestyle interventions that are precise and less disruptive.
Okay, let's tie this back to the EMF exposure question. The hypothesis is that EMFs, especially from 5G and other wireless technologies, can trigger a stress response at the cellular level. This response could manifest as changes in RNA activity, potentially leading to inflammation, oxidative stress, and other health problems.
And that's where the personalized dietary interventions come in. The idea is to use specific nutrients and dietary strategies to counteract these negative effects. Things like antioxidants to combat oxidative stress, anti-inflammatory foods to reduce inflammation, and so on.
So imagine you're exposed to a lot of EMFs. Maybe you live near a cell tower or you're on your phone all day. This study wants to see if a specific diet, let's say high in blueberries antioxidants and turmeric anti-inflammatory, can actually change the RNA activity in your cells, making them more resilient to the EMF stress.
And the beauty of this is the potential for personalization. Not everyone responds to the same diet in the same way. This research could help us identify specific RNA signatures that predict how someone will respond to a particular dietary intervention. Then we can tailor the diet to the individual's needs.
That's the future of medicine, right? moving away from generic recommendations and towards personalized strategies based on our unique biology. And I think integrating exercise is vital too. People in this study will also have to exercise and get good sleep in addition to the diet.
Yes, and that's where I think it becomes really powerful. If I can visualize RNA activity in thick tissue sections, maybe I can identify patterns of RNA expression related to specific lifestyle choices, including mindful meditation. Could meditation actually affect RNA activity patterns?
Potentially, it could lead to a new measurable biomarker for stress reduction, and that biomarker could be used to guide CBT interventions as well. The visualization provides compelling evidence for the effectiveness of the interventions, which can be incredibly motivating for patients.
And it's not just about meditation. What about the impact of exercise on those same RNA signatures? Could we identify the optimal type, intensity, and duration of exercise to maximize resilience to EMF exposure?
Exactly. We're talking about a truly holistic approach that integrates diet, exercise, meditation, and cognitive strategies to optimize our health in the face of a modern environmental challenge.
Now, of course, there are challenges. One big one is controlling for all the other variables that can affect RNA activity. Diet is complex, lifestyle is complex, and EMF exposure is complex. It's going to be tough to isolate the specific effects of each factor.
And the longitudinal aspect is crucial. We need to see how these interventions affect people over time, not just in the short term. Are the benefits sustained? Are there any unexpected side effects? It is a great study to go long term.
Absolutely. And that's why this research is so important. It's not just about finding a quick fix, but about building a deeper understanding of how our bodies respond to EMFs and how we can empower ourselves to protect our health.
So, let's say this study finds that a specific diet does mitigate the negative effects of EMF exposure. What are the practical implications? How could this information be used to improve people's lives?
Well, first, it could inform public health recommendations. We could start to see dietary guidelines that specifically address EMF sensitivity. And it could also lead to the development of targeted supplements and functional foods designed to enhance resilience.
Right, but I think it goes beyond that. It's about empowering people to make informed choices about their lifestyle. Knowing that a certain diet or exercise routine can protect you from the potential harms of EMF exposure can be incredibly motivating.
And that empowerment is key. Because, let's be honest, we're not going to get rid of wireless technology anytime soon. So, we need to find ways to live with it in a healthy and sustainable way. That includes proactively building resilience.
Yes, and for people who are particularly sensitive, this research could provide a roadmap for managing their symptoms. Instead of feeling helpless and overwhelmed, they can take proactive steps to protect their health.
It almost sounds too good to be true. I mean, are there any potential downsides or limitations to this approach?
Well, one concern is the potential for misinformation. If this research is misinterpreted or overhyped, it could lead to people making drastic dietary changes based on incomplete or inaccurate information.
And that's why it's so important to communicate the findings responsibly and to emphasize that this is just one piece of the puzzle. A healthy lifestyle is about more than just diet. It's about exercise, sleep, stress management, and social connection.
Another limitation is the cost and complexity of this type of research. RNA sequencing and advanced microscopy techniques are expensive and require specialized expertise. That could make it difficult to replicate these findings in other populations and settings.
And there's also the issue of individual variability. What works for one person may not work for another. We need to be cautious about making broad generalizations based on limited data.
So, what are the next steps? What kind of research would you like to see done in this area?
From a cognitive perspective, I'd love to see studies that explore the interplay between dietary interventions, EMF exposure, and cognitive function. Can a specific diet improve memory, attention, and executive function in people who are exposed to high levels of EMFs? And can that be measured via RNA activity correlated with a brain scan?
I'd be interested in seeing research that examines the impact of different exercise modalities on EMF resilience. Does aerobic exercise, strength training, or yoga have different effects on RNA activity and cellular stress response?
For me, I want to explore the potential of mindfulness and meditation to mitigate the effects of EMF exposure. Can these practices actually change RNA expression patterns and reduce cellular stress? Imagine a study where participants meditate regularly while being exposed to EMFs, and then their RNA activity is compared to a control group. That would be huge.
And it would be great to see this research extended to different populations and settings. What about people living in rural areas with limited access to technology? Or people working in industries that involve high levels of EMF exposure? How do their responses differ?
Yes, and it's important to consider the ethical implications of this research. How do we communicate the findings in a way that empowers people without causing undue anxiety or fear? How do we ensure that everyone has access to the information and resources they need to protect their health?
It all comes back to education and empowerment. We need to equip people with the knowledge and tools they need to make informed choices about their health and well-being in the face of a complex and rapidly changing world.
Absolutely, and this research, while still in its early stages, offers a promising glimpse into the future of personalized medicine and proactive health management.
It's exciting to think that we're on the verge of understanding the complex interplay between our environment, our lifestyle, and our cellular health at a whole new level.
Yeah, this technology imaging RNA in intact tissue is inspiring. Feels like a doorway to understanding the very mechanisms of well-being. It's like I could almost see the effects of my choices, my meditation, my mindful walks on a deeper level. Wow, 15 thick sections. That's pretty cool. If RNA activity patterns can be tied to things like stress, could this technology be used to find a correlation between meditation and specific RNA responses and thereby identify the exact biological mechanisms behind the feeling of peace?
It's fascinating that such advanced microscopy techniques are now available to study RNA in its natural, intact environment. This suggests that a much deeper understanding of cognitive processes is within reach, offering an unparalleled level of insight into the biological underpinnings of thought and behavior. If this approach can translate to practical cognitive remediation and treatment methods, the potential for improving human health is truly remarkable.
Knowing that this microscopy technique can track RNA expression in 50 hum slices opens up a whole new level of detail in understanding cellular response to exercise and sleep. It's possible that some RNA-based patterns might indicate optimal recovery windows or times for specific exercise types, enabling personalized workouts and sleep schedules for maximized results.
All right, so let's shift gears slightly and think about some real-world applications of this research beyond just mitigating EMF exposure. What other areas could benefit from this kind of personalized dietary intervention approach?
Well, I immediately think of mental health. We know that diet plays a huge role in brain function and mood regulation. Imagine using this technology to identify specific dietary deficiencies or imbalances that are contributing to depression or anxiety.
And then tailoring a diet to address those specific issues. Supplementing with nutrients that are lacking or eliminating foods that are causing inflammation. It could be a powerful tool for improving mental well-being.
Yes, and think about neurodegenerative diseases like Alzheimer's. There's growing evidence that diet and lifestyle play a significant role in the development and progression of these diseases. Could personalized dietary interventions help to slow down or even prevent cognitive decline?
Potentially. By identifying specific RNA signatures that are associated with cognitive decline, we could develop targeted dietary strategies to protect brain cells and maintain cognitive function. And again, measure any changes via this method of looking into cells via the tissue.
And what about autoimmune diseases? These conditions are characterized by chronic inflammation and immune system dysfunction. Could personalized dietary interventions help to reduce inflammation and rebalance the immune system?
Absolutely. There's a lot of research showing that certain foods can trigger inflammation in some people. By identifying those trigger foods and eliminating them from the diet, we could potentially alleviate symptoms and improve quality of life.
And it's not just about eliminating foods. It's also about adding in foods that are rich in nutrients and antioxidants. Things like fruits, vegetables, and whole grains can help to protect cells from damage and support overall health.
Yes, and it's important to remember that everyone is different. What works for one person may not work for another. That's why personalized interventions are so crucial.
Okay, let's go even broader. Could this approach be used to improve athletic performance? Could personalized dietary interventions help athletes to recover faster, build muscle more efficiently, and enhance their endurance?
Definitely. We know that diet plays a huge role in athletic performance. By identifying specific RNA signatures that are associated with muscle growth and recovery, we could develop targeted dietary strategies to optimize training and performance.
And it's not just about what you eat, but also when you eat. Timing your meals and snacks around your workouts can have a significant impact on your energy levels and recovery.
Right. And what about aging? Could personalized dietary interventions help to slow down the aging process and extend our lifespan?
That's the holy grail, isn't it? There's growing evidence that diet and lifestyle play a major role in aging. By identifying specific RNA signatures that are associated with aging, we could develop targeted dietary strategies to protect our cells from damage and promote longevity.
And it's not just about living longer, but about living healthier. We want to maintain our cognitive function, our physical strength, and our overall quality of life as we age.
Absolutely. And that's what this research is all about. It's about empowering us to take control of our health and well-being and to live our lives to the fullest.
So, to circle back to the EMF question, let's say this study is successful and they find that a specific diet does mitigate the negative effects. What are the challenges of implementing that on a large scale?
Well, cost is definitely a factor. Healthy food can be expensive, and not everyone has access to it. We need to find ways to make healthy food more affordable and accessible for everyone.
And education is key. People need to understand the importance of diet and how it can impact their health. We need to provide them with the knowledge and skills they need to make healthy food choices.
And we need to address the issue of convenience. It's often easier to grab a fast food meal than to cook a healthy meal from scratch. We need to find ways to make healthy eating more convenient and less time-consuming.
Yes, and we need to change the food environment. We need to make it easier to find healthy food options in our communities. We need to support local farmers and food businesses that are committed to providing healthy, sustainable food.
And we need to address the social and cultural factors that influence our food choices. Food is often a part of our traditions and celebrations. We need to find ways to incorporate healthy food choices into our cultural practices.
It's a complex challenge, but it's one that we can overcome. By working together, we can create a food system that supports the health and well-being of everyone.
Absolutely. And this research is a step in the right direction. It's providing us with the knowledge and tools we need to make informed choices about our health and our food.
Speaking of large-scale implementations, let's think about how this kind of research might impact underserved communities. I'm reminded of the farmer-to-farmer education programs in places like Zambia. Learning about the importance of soil health and sustainable farming practices reminded me of how connected our well-being is to the well-being of the earth.
That's a powerful connection, and it highlights the importance of considering the social and economic context when designing dietary interventions. In many underserved communities, access to healthy food is limited by poverty, lack of infrastructure, and other factors.
Yes, and it's not just about providing access to food. It's also about empowering communities to grow their own food and to build sustainable food systems. That's where initiatives like farmer-to-farmer education programs can make a huge difference.
Imagine incorporating principles of mindfulness and sustainable agriculture into these programs. Practicing mindfulness while working in the field could be a profound way to integrate life changes and find new ways to enhance health through an active life. They may have a unique meditation style to share, a cultivation of the soul.
That's a great idea, and it aligns with the principles of cognitive behavioral therapy. By helping farmers to develop more positive and resilient thought patterns, we can improve their mental health and their ability to cope with the challenges of agriculture.
And it can also improve their physical health. Farmers who are less stressed and more mindful are more likely to take care of themselves and to adopt healthy habits.
It's a holistic approach that addresses the root causes of health disparities. By empowering communities to take control of their food systems, we can create healthier and more equitable societies.
Absolutely. And this research can play a role in that process. By identifying the specific dietary needs of underserved communities, we can develop targeted interventions that are tailored to their unique circumstances.
Yes, and it's important to involve community members in the research process. We need to listen to their voices and to understand their perspectives. They are the experts on their own lives and their own communities.
It all comes back to collaboration and partnership. By working together, we can create a healthier and more equitable world for everyone.
So, thinking about future research directions, I'm really interested in exploring the role of the gut microbiome in mediating the effects of EMF exposure. We know that the gut microbiome is a complex ecosystem of bacteria and other microorganisms that plays a crucial role in our health. And there's growing evidence that EMFs can disrupt the gut microbiome.
That's a fascinating area, and it makes sense because the gut is so closely connected to our immune system and our overall health. If EMFs are disrupting the gut microbiome, that could have a wide range of negative consequences.
Right. So the question is, can we use personalized dietary interventions to restore the gut microbiome and mitigate the negative effects of EMF exposure? Could probiotics, prebiotics, or specific dietary patterns help to rebalance the gut flora and reduce inflammation?
That's exactly what I'm thinking. And it would be great to use this advanced microscopy technique to study the effects of different dietary interventions on the gut microbiome at a cellular level. We could actually see how the bacteria are responding to the diet.
And it would be important to consider the role of exercise in this process. We know that exercise can also have a positive impact on the gut microbiome. Could a combination of diet and exercise be even more effective at mitigating the effects of EMF exposure?
Yes, and let's not forget about the role of stress. Stress can also disrupt the gut microbiome. Could mindfulness and meditation help to protect the gut from the negative effects of stress?
It's all interconnected. Diet, exercise, stress, and the gut microbiome are all working together to influence our health. And by understanding these complex interactions, we can develop more effective and personalized interventions.
So, from an exercise perspective, I'd like to see more research on the optimal timing of exercise in relation to EMF exposure. Is it better to exercise before, during, or after EMF exposure? And what type of exercise is most effective?
That's a great question. And it's one that we don't have a lot of data on right now, but it's definitely worth exploring. Maybe certain types of exercise are more effective at clearing out toxins or reducing inflammation after EMF exposure.
And it would be interesting to see how different types of exercise affect RNA activity in different tissues. Does aerobic exercise have a different effect on RNA activity in muscle tissue compared to strength training?
Yes, and what about the impact of sleep on EMF resilience? We know that sleep is crucial for recovery and repair. Could optimizing our sleep habits make us more resilient to EMF exposure?
Absolutely. And it's not just about getting enough sleep, but also about the quality of our sleep. We need to create a sleep environment that is conducive to restful and restorative sleep.
And we need to be mindful of our exposure to EMFs in the bedroom. Things like cell phones, laptops, and other electronic devices can emit EMFs that disrupt our sleep.
So, from a sleep perspective, I'd like to see more research on the impact of different sleep habits on EMF resilience. Does sleeping in a dark and quiet room, avoiding caffeine and alcohol before bed, and establishing a regular sleep schedule make us more resilient to EMF exposure?
And from a mindfulness perspective, I'd like to see more research on the impact of different mindfulness practices on EMF resilience. Does meditation, yoga, or deep breathing exercises help to reduce stress and protect ourselves from damage?
Yes, and it would be great to use this advanced microscopy technique to study the effects of different mindfulness practices on RNA activity in different tissues. We could actually see how these practices are changing our cellular response to stress.
It's all about finding the right combination of diet, exercise, sleep, and mindfulness that works best for each individual. And that's what this research is helping us to do.
Well, this has been a fascinating conversation. I think we've covered a lot of ground and explored some really exciting possibilities. I'm feeling a lot more hopeful about our ability to protect ourselves from the potential harms of EMF exposure.
Me too. And I'm excited to see what the future holds for this research. I think it has the potential to revolutionize the way we approach health and well-being.
Absolutely. And I'm grateful to be a part of this conversation. It's inspiring to see so much progress being made in the field of personalized medicine and proactive health management.
Thank you all for joining us today on the Vitality Equation. We hope you found this conversation informative and inspiring. Until next time, stay healthy and stay vital.